Haha, he remembered. So this is going to be the last class we do on Twitch today. As a heads up for those of you that are not technically registered, next week is all going to be on Zoom. Reason why are those term project presentations that we've been talking about. So if you didn't check the emails or didn't see the announcement emails, term project. Next week, we'll do your presentations and I'll wrap up everything else that we haven't talked about on Tuesday. So 7 minute max. We have 75 minutes of class. That's about what we can fit in for student presentations. I don't know why I thought we'd have a lot more time to play with. Um, I didn't want to give you all just like 5 minutes to talk because I know you're doing neat stuff and you probably want to show it off. You don't have to go the full 7 minutes if you don't want to. I know the goal here is not a strictly a massive term project, but I would like to show off the cool things that you're doing. So I'll record it and I'll make the recording available on internally anyway. Um, again, you don't have to have it fully done by the time of your presentation. Just make sure that you can show something off. As with the deliverables that I mentioned, the due date for those isn't until the 29th. So that's the Thursday of finals week. So if you want to wrap anything up, finish anything when maybe you have a little bit more free time, it's kind of why we have that. So show us what you got, tell us what you did, and we'll have a good set of presentations. So there is that. Yeah, as I keep saying it, I realize it could be taken the wrong way too. I want it to be, let's be very clear. This extension is not so that you can work during finals week on it. It's flexibility. So don't think that I want you to put an extra week of effort into it. It's just crazy semester. Let's ramp down a little bit. But yeah, at least show us something that you've got going on. And yeah, we'll do that. I also, I think well, I know I sent an email about it. The last assignment is the Unity roller. So basically, you're going to set up some terrain, set up some textures, add a ball, add some walls, bounce around, all kinds of fun stuff. Typically, I would make this a full assignment. Looking at all of these stuff I have assigned for you, I felt would have felt really bad about assigning this as required. So this is just extra credit. You don't necessarily have to do it. We have more than enough points for the semester. So if you feel like you need extra points, feel free to do that. Just remember that if you hit 1,000 points in Blackboard, that's a 4 point. So that's what we're basing the semester off this time around. I intentionally provided more points that are available just in case if people ran into issues throughout the semester. My goal for you is so that you all get experience with this stuff rather than go crazy over your grade. But extra credit if you want to do it, not required. Other things, so I posted this in the Discord chat. I thought it was pretty cool. If any of you want to play with Unity, how many points are a 4 point? Um, sorry, it's 1,000 points. I don't know if I cut out or if the guy cutting my neighbor's lawn is coming through, but 1,000 points is the 4.0. So that's in the syllabus, by the way. I came across this. So we have, obviously, we're doing Unity stuff. I started looking up procedural generation in Unity. Came across this cave generation tutorial, which looks like it could be fun if you want to play around with it. I could see generating an environment like this and dropping like a ball that you could roll around in there and watch it kind of navigate this environment. Does some cool things like marching cubes, cellular automata, or sorry, marching squares. It doesn't make sense to do squares because you'd think they do cubes. God, that guy is right out there. Awesome. I think this stuff is fascinating, so I figured I'd share that with you. Also, the person who made this, he is somebody that I've been kind of seeing pop up in a lot of generative art stuff. So I thought it was kind of neat. I think he does, it's Sebastian somebody or other. I'm not going to pronounce his name correctly, but I've seen him with like the coding train guy do stuff, which I find interesting. So there's that. Feel free to play with it if you want. So we've got that. We've got that. I did this earlier because I thought it was kind of fun. Another little P5 project to show off. Figured it was time for me to learn a little bit about drawing in Polar. So here I'm just kind of figuring out some points in polar coordinates and drawing lines. And because it's in P5, it took me 15-20 minutes to do this. We can add color. We can make them Bezier curves. Bezier. Nothing tricky, just basic P5 drawing. And you could do this in WebGL pretty easily too. It'd just be line loops or lines. Um, the code's actually really easy for this. All the code that I have in here, it's basically just to make things more complicated. But let me pop this up just so that I can show you. Because I think it's cool. And if I think it's cool, you're being forced to see it. Where's my points being generated? Really, it's just converting XY coordinates to polar. So multiply some radius by the cosine of some angle, multiply that radius by the sine of some angle, then you have an XY coordinate on a unit circle, multiplied by r, which is the radius of that unit circle. Then you just draw based on where that point is. I randomized it, but you could easily just march along that circle and draw things. And I showed this to my daughter earlier, who is doing um, they're doing like limited geometry in their class. So they're doing like draw a square and then make it a 3D cube and draw a circle and draw lines all along the points. I'm like, oh, that's kind of neat. Fits right in. So there's that. And if you want to try it out, I actually shared the P5 sketch. I think I did that on Twitter, but yeah, that's my stuff for you. I like showing off fun things. So let's do some 2D. Last time we were doing 3D, right? Let's see, what did we wrap up at? We finished up the scripting, we did the ball roller. Oh, that's right. I was showing you exporting. So the thing with exporting your Unity projects, I didn't get to that, did I? When you do build settings and you go to pick an export platform, I picked WebGL, and then I'm not going to do it here because it would take forever and a day to switch and then build. It needs to be running on a web server. For some reason, I was thinking I could just run a little local Python web server host, and it seems that there are some settings in that default Python http.server that doesn't serve the correct thing. So what I would do if I were you is if you want to take your project and export it to the web, do your export and then upload it as a package or as a like a zip file to Google Cloud and then unzip it up there. Or if you're doing it to the EOS website, do the same thing. Export it, you're going to get a folder, zip it up, plop it on your server, unzip it, run it. All right, and you get which I can show you really quickly. I keep saying really quickly, and then it takes 20 minutes to do because Unity. I made so many folders just the same thing. Class 3D ball. Yes, builds. So I created this file, and then you get something that looks like this when it doesn't have a web server. Basically, what I was just kind of saying was, go ahead, zip up this folder. I've got 7-zip here. Upload that to Google Cloud, and then you're pretty much set, or whatever web server you want to run. But there's that. Okay, so 2D. For almost every deployment I've ever done, npm run build. I could not speak to that. I know very little about Node.js other than running it. Are you talking about building it as like a executable application? Can I have it pull from a GitHub repo? So you could push it up to GitHub and do GitHub pages. There's nothing crazy here, yeah. So if you were to push up all your build scripts to GitHub pages and then you point it at like the index.html, yeah, you can do that. You might run into the thing where uh, GitHub.io or GitHub Pages is looking for like a Jekyll build. You can have it ignore Jekyll. There's a command that you can do that. I've had some projects where they try doing a Jekyll build and it fails because it's just a straight HTML page, and somewhere it doesn't care. So, yeah. But yes, there's nothing crazy here that would prevent you from using GitHub. All right, let's talk 2D. So, 2D graphics, what do we have here? It's a little bit more simple, right? We only have an X and a Y to consider. We don't have that nasty Z to worry about anymore. So here you have a 2D soccer field, kind of a top-down view, right? Everything that we have done in Unity and 3D, the real difference to 2D is that it's just preloading different settings in the Unity editor. Basically just removing a dimension from everything. You probably have seen every time I've gone to add a rigid body, there's also a rigid body 2D component that I could load in. So you kind of see everything that's in there. Now, we're going to talk about these really quickly, and if I can get to shader graph today, that would be cool too. But some of these are out of date, I should mention as well. So if you go to create a new Unity project, I don't think you see all of these templates. This was Unity 2019. If I were to go new, so you see high def RP, universal render pipeline. We've got some mobile AR VR types of projects where this basically just configures Unity to use this particular thing. If we get to the shader graph stuff, you need to do the universal render pipeline because it requires this rendering pipeline for the shader graph stuff. Or high def RP, I think, has it too. Normal 3D will not work. You can install different templates for Unity. You can add them in. This does change over time, basically. So what are these different things and why is my taskbar not getting out of the way? Back to full screen. Not gonna do it. Okay. So 2D, we get a 2D scene, which means we have sprites instead of meshes. We have an orthographic camera, standard two-dimensional stuff. 3D, you get a 3D scene, models, rendering pipeline, everything you need. If you add on the extras, which is going to be various pipelines, you may get a post-processing stack, which basically helps with the rendering process for 3D. If you go the high def model or the universal template, you might start seeing it take even longer to load. Basically, we are adding in extra stuff to kind of shorten what we're going to say here. For instance, high def RP, basically you're supporting specific shader models. So DirectX 11 and up for the 2019 version. I didn't look up what we currently support, but my guess is it's probably DX12. So let's talk 2D here. 2D games in Unity are absolutely a thing, or visualizations or simulations, whatever you're doing. Wizard of Legend is one of them. Was a pretty popular roguelite that came out a while back. I'm not going to go through this whole video, but if you are, you know, obviously I'm a fan of Binding of Isaac and this kind of a genre. This game was made with Unity. So this is Wizard of Legend. It's one that I've never actually played, but I've heard lots of good things about it. I tend to be more of a fan of games where I can only use my keyboard. This kind of looks like it's mouse keyboard centric, maybe controller centric, I'm not sure. Gungeon falls in that realm too, but they did such a good job that I didn't care. But anyway, this game is kind of a good example of what you can do with Unity in terms of building something. So you can add, obviously, particle effects. You can add on anything you find in the assets store. You can do shaders even, which is lots of fun. So what do we care about and why is it different? We're back to the 2D plane, so XY. The view is different. Like I mentioned, this is an orthographic camera. and we have sprites instead of models. And basically what that means is that sprites are just going to be different object types. If I want to do an animation, for instance, I'm not going to build up a Blender model, rig it like with a skeleton, and then move the joints and stuff around. I'm going to load in a sprite sheet where I've got an animation as separate frames, and then I just load that onto my sprite model or my sprite object. We don't have terrains anymore, we have tile maps. So these are basically going to be, again, two-dimensional blocks where you would draw an object or draw a sprite or just directly draw if you want to save on processing power. So we have this notion, and if you're going into something like Godot, well, there's a lot of good 2D examples in that engine as well. Obviously, there's a lot for Unity too. If you check the asset, not the asset store, the learning store, lots of nifty examples there. But let's just kind of jump right into it because that's how I like getting into these things. I'm going to be following this particular tutorial at a high level. I think it's 12 parts. Not going to do all of it. It would be a lot of time and effort, but we'll do the basics. We'll leave the rest as an exercise to the student. Ha 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 ha. Okay. It's a fun professor joke because as an undergraduate, I remember my faculty telling me it's an exercise to the student. It's so much fun. So I'm going to do this thing where we go back and forth to the slides versus Unity. So we're going to create a new game object. We're going to add a 2D sprite to it, and then we're going to control it. All right, so let me bring this over here. We don't want the 3D one. We don't want voice meter. But this took probably 5 minutes to load or so. So I did the smart thing and preloaded Unity today. All right. Move stuff around off screen, and there we go. So this is our 2D scene. Looks pretty bare bones, right? We need to get rid of you. Okay. Looks like there's another vaccine opportunity. I just didn't read the email, but closed it. So 2D scene. We don't see our little gizmo anymore for manipulating 3D space. I'm panning with right-clicking, and I'm middle-clicking, same thing. Zoom in, zoom out. Kind of looks like that canvas when we started drawing text last time too, right? So let's go ahead and add a player. So I'm going to create an empty game object. Let's say player object. Now I've got a thing, right? There's my my sprite, or sorry, my object, not a sprite. We need to add a 2D sprite. And I'm just going to add a square. You can make it whatever you want, but now we have I'm just going to leave it called square for now. This is my sprite. Okay, I can change its color if I want. You know, let's do that nice little rose, little pink, sure. And I'm going to reset you to the origin, just because. I could leave it as a square, or I can add on an actual sprite. I'm going to be lame and just use a pre-baked sprite. So I could pick, let's see. Make you a check mark. Make you this. Where did my sprite stuff go? UI? No. Okay, I seem to be just randomly losing assets. Fine. You know what? Fine. We're going to leave you as a rounded rectangle. There should have been a knob, which gives me like a little thing. Undo that. All right. You are a small rounded rectangle. I hit play. I've got a rectangle. It's probably going to be tiny. But this is where I would load in like a sprite sheet from some other source. You know what, let's go back to that. We'll just leave you as a big ol' square. Oh, now they're just not rendered in? Okay. I am impatient. Sure, you can be that thing. Why not? Looks like we've got a knife cleaving a bone. That's my sprite. It's gorgeous. Now, let's go ahead and add on some control code. So I'm going to be lazy and not organize my scene, but we'll call this player controller. Going to attach it to the game object, not the sprite. Need to actually instantiate it. Now let's attach it. Thank you. We now have our script. And let's get this moving around. So I'm going to do some copy pasting here. But basically what I'm going to do is I'm going to add on speed, I'm going to add on some hit points, and I'm going to add on some movement capabilities. And what we're going to be doing here is we're going to get the horizontal and vertical move keys, and we are going to transform our player directly. All right. And I should mention too, when I was playing around with this last time, I think I may have made a typo, but I couldn't quite get the whole thing to work. Also, the suggestion for the the automatic text parsing thing doesn't seem to work very well in Unity because I think it's expecting a .cs proj file. All right, so you go and update. This is going to look absolutely awful because I don't have a formatter installed, even though OmniSharp is going. Let's just do this. Use Vim. Good enough. So get the movement from the input manager, create a vector 3 for it. We still have vector 3, even though we're in 2D space, and we're going to apply that translation, just moving the object around. What we should see now, once this compiles down, we should see our public variables pop up in here, so we'll get a speed, we'll get our hit points. So now if I hit play, we compile and we build, and I can move my little thing around here. Nothing too crazy. Let's bump up our move speed a bit. Focus. Now it's a lot faster. Again, move speed is going to be a multiplier as well on your input versus time versus direction. So that's just a modifier there. Good so far? Just a pure object, no physics to it yet. What we're going to do now is make it a physical object. So we're going to go ahead and add a rigid body 2D. We're going to turn off gravity so that we don't just fall through the world. And in this case, for rigid body 2D, that means gravity scale is 0. So it's just a scale factor here. Now we can also notice that we had some kind of janky motion. So we're going to interpolate its motion here. And basically this just does, tries to calculate along the way what its position should be. And we want to now go ahead and add this into our script. So let's get a reference to it. So we'll call it up, private rigid body 2D, RB equals game object dot get component rigid body 2D. You know, I'm going to leave this in here just because I mentioned it last time and I didn't do it. If RB equals null, debug.log player start can't find rigid body 2D. Okay. So this should compile okay. Unless if I typoed. So if we hit play, we're going to get slightly different, well, we're not going to get slightly different behavior. It's going to be the same because we're just translating its position, right? Nothing different yet. I want to show you that whole rigid body error message though, because if I, let's get rid of this component and I hit play, I should get an error. You see it down here. Can't find rigid body 2D. So it's my assertion that we have a rigid body. Again, the reason why we would do that is that not everybody, it's possible that one person writes the code and one person works on the front end, right? So those kinds of things can be helpful. Now, let's go ahead and use fixed update instead of update for changing. I'm going to comment all this out because we don't need it anymore. No, this one commented out. So update we'll leave there just for fun. Void fixed. Oh, I copy and pasted that. Good enough. So I'm kind of going through this quickly because this is the same thing that we did last time with the ball movement. It's just in 2D space instead of 3D space. All right, so we're going to get the input. We're going to multiply it by our speed. And then we are going to create a vector and add a force to that. So here we can actually go down to 2D, a 2D vector, because we're just applying forces in the XY direction. The position, the translation, the specific position in the object transform has XYZ, but our physics object only has XY. So we can go ahead and try this out now. Compile down. And we should get something that feels like it has weight. Good so far? So we have that kind of, I'm holding one of the keys and it's you can feel it's got a mass now basically. Just kind of feels like I'm guiding a bowling ball around with a stick or something like that. So good enough, we have movement. All right, next step. Let's make it look like we actually are doing something. Our plain background makes it hard to actually see if movement's actually happening or not, right? We don't know what's really going on. So let's add in a background. So basically we're going to draw this type of a spacey scene, and we're going to have our object be drawn on top of that. And what we're going to do is we're going to tile it. So we're going to take one image. So there's this one here, and it's basically set up to be nicely tileable. So I'm going to pull one of these down, and we can just keep overlaying them, and it's going to look like one continuous big scene. So it's that kind of nice. If I had 1, 2, 3, 4, 5 of these lined up next to each other, it would look like one continuous image, not like a bunch of janky breaks at the edge of each one. This is something that you can do in a tool like Photoshop automatically, by the way. There are automated, I don't remember what the exact tool is, but you can like generate a texture in Photoshop, or I think even GIMP has it, and then just have it seamlessly tile. So what we want is we want to add this to our project. So I stuck it on my desktop out of sheer laziness. Space BG, drag it in. Now we want it to be a full rectangle. So this is mesh type, which is, no. Where did that go? Mesh type, oh, it's right here. I can't see. Full rect. And we're going to add a game object for it. Apply, okay. New game object, empty. We'll call this background, F2, background object. And we're going to add a sprite to it. Maybe it is a square. BG sprite. We should probably rename these things, I guess. Player sprite. Okay, got a sprite. Looks delightful. Except we want this to be an image. So, add sprite. There. So I just dragged my image here. And we want to set its mode to tiled. We want to set its width and height to be 100 by 100. All right, now, hey, look at that, I've got space. And you can kind of see it. There's the 2 dots here, 2 dots here. It lines up nicely. If you zoom out far enough, you can see the pattern. But if you're zoomed in, you're not going to notice. And we also want to, I forgot to reset its location. So actually, this is kind of a nice little thing because I forgot a step. You can go back. I clicked background object. I had something else selected before, so that kind of transformed to where I was in the world. So you see its position is offset here. I want to reset its position. And we see it shift slightly just so that things line up nicely. But now if I hit play, well, the camera's not attached to my player, so nothing's going to happen. Yeah, that was dumb. Nothing's going to happen. We have to add on our camera follower, so we'll do that in a moment. Basically, we don't want to just parent the camera to our player. We want to add some code for that. But one thing that we should do here is we should add some layering, because I think, oops, I don't want to do that. Undo whatever I did. Let's move you down here. If I hit play, to me that would be separation. So again, for reference, I'm just kind of following this tutorial, and that was their thing. I can see your point though, but actually no, sorry. So are you talking about adding it to the scene, like adding a bunch of sprites? Because there is a reason for that. So yes, there is a reason. If I were to just add sprites to my sample scene, I would not be able to add like a rigid body to all of them. I would not be able to add any other components. It would all be tied to that scene and that object. So we want to add it to the game object itself. And I guess maybe you could add the rigid body to the sprite. That one I'm not sure on then, but yeah. So we have this. Let's go ahead and add some layers now. So we want to add some sorting layers to this scene. Think of it, and I've got a nice little onion drawing here. If you've ever done web development, you might know there's this thing called a z-index, which basically is what is being drawn on top of what. We did that with our clipping and with our, our z buffers in WebGL, but we can set that up here in Unity using layers. So what we're going to do is we're going to add a background, entities layer, and a foreground. Foreground's going to be like actually, entities is going to be your player. Yeah, player to entities layer. Foreground would be in front of everything. Entities would be, say, your objects or your enemies. Background would be that nice little spacey thing. So this is something that we can do here in Unity. Now, what we want to do is add some layers here. So here we have a bunch of user layers. I want a sorting layer. So I want to add background. I want to add entities, just follow on the slides, and foreground. And you can move these around as well too. Like if I want the default things I don't like care to sort manually, I can just have it be in between entities and background here. So I'm going to add my background object to the background layer. No, I'm going to add my background sprite, sorry. Am I looking at the wrong spot? No, it is background sprite, background layer, player sprite, player layer, entities layer. So again, what I did here is I added sorting layers. I clicked the sprite object, not the game object, and then we have a sorting layer thing here. So we can basically force ordering in this case. And if I hit play, it shouldn't look any different. Like we should still see the player on top here. All right, unplay. Okay. Just for funsies, do we have a better... Let's do a hexagon. Okay. Yeah, that's a little better. Just to have some notion of something a little bit bigger there. Obviously, yes, I could scale it. I hit F, by the way, to focus again. Same thing here. So let's add on a camera follower. So this is going to be, again, very similar to the camera follower script that we had in 3D land. Go ahead and build you. Let's add some code here. Copying off screen, as is tradition. Oops. Yep, there we go. So what we've got going on here is we have a reference to our player. We're going to have a lerp speed, which if we don't remember, lerp is just short form for interpolate. Basically, we're just smoothing out our movement transitions. So we're not going to have like a janky camera following us. We're going to make it nice and smooth, and we're going to define an offset, which, again, this is the same thing as last time. Get the initial distance of the camera to the player and just kind of keep that throughout the entire run. And have this awful spacing here just because things are so... Yeah, good enough. If you copy and paste from the slide, it'll look a little bit better on yours. I've got such big font here that... there we go. Let's go back a few. Good enough. We'll go to that spot. So we also have this function lerp as well. So this is part of vector 3. Basically, it's going to do that nice smoothing for us. And again, we're going to stick it in late update so that it's the last thing that happens every frame. So we're going to hit save, or I'm going to hit :W. Let's compile. And let's camera. Camera script goes on the camera. And our player object, oops, where's our script at? Okay. Player object goes onto the camera controller. And now we should get functionality here. Whee! And hey, look at that. A little bit janky, which is kind of interesting. I don't know if that's just my computer running slow or what, but we do have some rigid body adjustments to make. So what I want to do here is let's hit save. So my player object, I want this to be mass 0.25 and linear drag is 5 instead of 0. And then my player script, I want my move speed to be 1, right? Bigger, please. Move speed 10, not 1. That was 1.0. Move speed 10. Let's try this again. I'm curious if I'm just lagging or not, because normally this doesn't like jank along there. Yeah, it's got to be just my computer right now. You can kind of see it like jumping a little bit. It shouldn't be doing that. So I don't think that I screwed anything up, but it's always possible. All right, so we have a 2D sprite moving around a quote-unquote infinite 2D space. Let's see how far I can take this. So I think we're right in the middle. Let's increase our speed a bit. You can kind of see it looks nice and the background's like not jumping along. That's a nice side benefit of being kind of zoomed in on your background. But yeah, we do go um, off the map. So you would, if you were making a game, you would have to make sure that like you bound the camera so that it doesn't go beyond. Um, and camera crunching is a topic for another day. So we have player moving around. I may pick and choose to start skipping some things just to kind of move along here, but I would like to show you at least bullet firing. Because we've talked about colliders and stuff like that before. We haven't really talked about dynamic objects. So if you want to start spawning in, say, something like bullets, for instance, so in our little 2D game, we'll make a little space shooter type of a thing. Um, Dynamic content is basically I'm going to instantiate a game object and then destroy it when I'm done with it. And you would basically track your bullets with like a list of game objects, which are all tagged bullet or something like that. So what we're going to do is we're going to create a game object, give it a sprite, add a rigid body 2D, add some code, and make it a prefab. So that's basically what we're going to be doing here. Okay, let's do bullet firing. There we go. So, new object, we'll call this bullet object, gets a sprite. Nope, not an empty game object, thank you. We would like a 2D sprite. Make it a circle just for fun, we'll call it bullet. And we need a rigid body 2D on you. 0 gravity. Nope, not negative gravity, 0 gravity. Right. So we have that. You get a bullet script. So we'll call it bullet controller. And you get some public variables. And I've got the start already in my buffer here, so let's tab you over. All right, so bullets are going to have a speed, they're going to have a target vector, they're going to have a lifetime and amount of damage. So you can kind of see what we might care about for, if I'm shooting a laser or a bullet or something at another character. What speed does it go off on? What vector is it following? How long is it alive? Very important, by the way, to have a lifetime on your bullets, because if you just keep spawning them, eventually you're going to run out of memory. So make sure that you get rid of them after a certain point in time, or after they, say hit something. And how much damage does it cause? Basically, how many hit points would we take off? We are going to get a reference to our rigid body and add the force to it. So we have that. Update is going to, and that guy's going to town on my neighbor's lawn, it sounds like. All right, so update. Not necessarily a physics thing here, just call it once a frame. We're going to decrease its lifetime if we run out of time. Let's destroy the object. So we're basically just destroying the self reference here, destroy game object. This would be like your equivalent of this. All right, so we have that. Now, let's turn it into a prefab. Sorry, let's compile, and then turn it into a prefab. Need the Jeopardy theme song up and running in here. Okay, we need a prefabs folder. We're going to drag our bullet in there. Interesting. We're going to remove this reference. And we have a prefab. So what we're going to do now is we're going to give our character the, let's make this a little bit smaller too. Let's give it 0.25, 0.25, 0.25. So bullet's a little bit smaller now. We need to add it to our player. So our player needs the ability to control it. So we want a reference, public game object, bullet prefab. And we're going to have to shoot it. So let's go ahead and add on some update code. Told you we were going to need this again. If we hit the space key, we're going to create a bullet instance. And this is kind of the magic here. Instantiate a bullet based on the prefab, get a reference to it, and then set its target vector. So its target vector is the direction it's going to travel. This is where you would add some trickery, where if I'm holding the left key or I'm moving in one direction, shoot the bullets that way. Or grab where the mouse cursor currently is and draw a vector that way. So you can kind of aim based on that. And if we keep going with this, well, I think we add on the mouse movement thing. But we need to instantiate and then it destroys itself later on. Okay, so we have that. So we're just going to hit space, shoot a bullet. And it's going to go 1, 1. So it's going to kind of go down and right. And one thing we want, let's make sure we reset our oh, damn it, I didn't want to do that. Reset our transforms just so that it's at the correct position. Bullet, I wanted you to be smaller, so 0.25, 0.25, 0.25. I had that on the sprite and we want it actually on the game object anyway, just for collision detection purposes. But we should, if I didn't screw something up, be able to fire a bullet in a single direction now. Nope, it did not. I forgot to add the prefab to the player controller. So player object, player script, bullet prefab, we don't see it anywhere. Need to link that up. This should work now, I think. Object reference, oh, there it is, but it's not moving. It should be moving. That's interesting. What did I do wrong here? I think I screwed something up somehow. Did I want gravity on? Maybe I wanted gravity on. Oh. Ha, I see what I did wrong. Okay. I forgot to add my bullet controller to my object. So what was happening was I was spawning the thing in. I'm leaving seeds in space. There you go. It's a space seed. All right, gravity back to 0. Let's try this again. There we go. So we see they're all moving in the same direction. I've given them a push in the up and the right because we're going +1 in X, +1 in Y. So let's fire one and let's follow it along. Just kind of guide our child in its destination. Boop, all gone. So that's demonstrating the lifetime. We can spawn a whole bunch of them. You know, let's actually do that because we can do this pretty easily. Instead of get key down, let's just call get key. All right, so I hit play again. Whee! Kind of look like the neon cat. Nyan cat? Neon cat? So these are all separate bullets, by the way. If I look at my scene, look at all of these instances there. Hey, now let's follow it. Whoop. There we go. It still looks like I'm leaving seeds in space. Leaving a little snail trail there. Okay, so any questions on what I've done so far? Again, I'm just walking through what are in the slides, which should be up in Blackboard if you want to play along at home, which I would recommend because that's, at least for me, that's how I learn. If you wanted to fire in 6 directions, you just replicate and have them go in different directions, so spawn 6 different bullets. Sure, yeah. So let's see here. So let's undo this. Get key down. So if I hit space, I'm gonna send a bullet in this direction. Let's do 2 of these. So I'm gonna go ahead and replicate this. Let's call this go 2, bullet 2, bullet 2, and let's go in the negative direction. Shouldn't be anything wrong with this. I'm just gonna spawn 2 bullets. Because it seems sloppy. Why does that seem sloppy? It's a legitimate question. I'm just curious what your line of thinking is. It's getting really warm in here all of a sudden. Somebody bopped the heat up. It's getting hot. Whee! That's kind of trippy. So let's talk about this for a sec, because it's a legitimate question. If I were to go ahead and want to define different firing patterns, this might not be the best way to do it, right? Yeah, sure. But that fire to function is going to need to know the direction, right? So we could just wrap this in a loop, instantiate bullet 1, send it in vector 1's direction, and then vector 2, yeah. One thing that we're probably not gonna get to it because I want to probably leave with AI. Please. I should also mention too, I don't know if any of you are Google Slides users for your personal life, but if yours like started getting really wonky looking, like the text looks all doubled and god awful, your ad blocker is probably interacting with the slides. I noticed this last night. What we can do is, where's it at? You can add on a scriptable object. This is something we're not going to get to today, but if you want to add on different guns, for instance, you can basically create things or assets that you spawn in, and you can give it firing patterns and stuff like that. But it's still going to basically boil down to the same thing. Create a copy of a prefab, instantiate it, and send it along a particular direction. Keep in mind, I guess, the reason why we're doing it this way, and your mileage may vary based on what game you're doing, obviously, right? If we're doing a game like this, every bullet needs to have its own collider, it needs to have its own physics. It's basically its own object. So in some way, we would need to still spawn them. Now, you could probably parallelize this too if you wanted. I have never done that in Unity myself, but I'm sure you could split off like a thread, set of threads to instantiate 500 bullets or something like that if you wanted. But let's get rid of this for now. Okay, so we have our bullet. Let's add another character. Seems like another course. No, it's just an extension, honestly. But this is kind of dipping into the game design area a little bit too. So maybe it's a Professor Woodring question. We're just let's still keep this in the graphics realm. We're drawing sprites and we're adding physics to sprites. We're not making games, so I wouldn't want to tread on anybody's toes here. But let's talk AI, because we want to add on another character. We want to be able to draw their sprite and have them move around the screen and do stuff. Well, what do we need for enemy characters? We need an object. Since we're in the 2D space, we'll add a sprite to that object. We could turn them into a prefab if we want to do like a gauntlet style game where we just keep spawning enemies. This kind of depends on what you want. If we're in 3D space, it's a model, not a sprite, right? We're going to need a rigid body of some kind too, because they're going to be able to interact with the environment, and then we're going to have to script them out. What does a script entail? Well, a enemy needs to be able to move. And the level of intelligence that you give an enemy just kind of depends on your script. They're also going to need to be able to make decisions, have attributes, maybe hold weapons, drop items, typical game stuff. But what does autonomous movement mean? I could give a enemy sprite or another sprite. I could just have it wander around. So just pick a direction and head that way. I could have it try and follow the player, calculate out the distance from the player's transform to my current transform, generate a vector from that, and head along that path. I could just kind of pick a random location that I want to go to and go that way. Do a drunkard's walk where I just kind of head in one direction and then I figure out if I'm wobbling left or wobbling right or going backwards or falling over or something like that. Lots of things we could talk about with AI. But for a sprite, or sorry, for an enemy here in this little example, same thing as a player. So let's go ahead and add them in. I forgot to Alt-Tab to you because now we're going to wait for you to compile. So we need an object, we need a sprite. So 2D, nope, empty. Enemy object, we need a sprite. There's probably a quicker way than right-clicking and doing sprites, and then square, enemy sprite. We need to give you, let's make you red because you're angry. And let's make you a character. Perfect. Reset your position. Nope. Reset your position. Reset your position. Red, let's scale you up. So let's make you 2, 2, 2. Hey, look, we have an enemy sprite. Look at that. Enemy object needs a rigid body 2D. We want 0 gravity. We want to interpolate. And we need colliders. So let's add on a circle collider 2D. Let's add on a second circle collider 2D. Reason why, if you remember colliders from last time when we were picking up the spinny cubes, those had colliders on them. This collider is going to tell us if we interact with it or not. And actually, we're going to do something tricky here. We're going to make a really big collider, and if the player interacts with that collider, the enemy's going to start following the player. And if the player leaves that zone, the enemy's going to forget that the player exists because I can't see it anymore. Right? So here we see, players here, enemies here. The enemy collider is this little guy right here. Well, let's play with the sizing. So on over here, I'm going to make this bigger and hide my chat for a moment. So if you're talking to me and I'm ignoring you, I apologize. First collider, 0.009. Oops, that's way too small. 0.09. So you actually see its collider is right there. Let's make it a little bit bigger so we encapsulate this object, deviating from the slides just based on the sprite that I have here. And we want to make it so not a trigger, okay? The other one we want to make, let's make it 1.5. No, let's make it 10. Yeah, that's good. That's way too big. 5. Yeah. 3? 3. Good enough. So this guy has 2 colliders now. The inner one we'll use to see if there's a collision that occurred with our bullets. The outer one's going to be our player tracking, and this is probably where we're going to end today because we're starting to get a little bit deep into this. So, enemy object. The bigger collider, we want to be a trigger. And if you remember from last time, the reason why we make it a trigger is so that we don't bounce into it. It's not a physical object. We want to trigger the on trigger enter functions here. So I'm going to hit save, minimize this again. So what we want to do, this is the logic that we're going to implement here. We're talking about this other sprite. So if we want to check if we have a target to follow, a target would be you, the player, or maybe if you want to have it interact with other entities. If I have a target, follow it. If I do not have a target, sit there and play dead. If a target comes into view, change the fact that I now have a target. If a target does not come into view, do nothing. So this is where we're kind of like walking through what a enemy AI might be thinking of. Or since this is not strictly a game course, maybe we're doing a simulation where we have little people walking around and we want to sell, maybe somebody's on the street and they want to sell you something. So they see a target and they acquire you and they come running up to you with their little cards. Hey, buy my junk. Buy my mixtape. It's a fire mixtape, I hear. So, attributes we need. Enemies need a speed, they need a target, and they need a rigid body. I have this hide and inspector tag here because if you want to make a public variable but not show it in the inspector, you have to add this little decorator here. So we have our enemy. Let's give the enemy a script. Enemy controller. All right, we need some public variables. Public, float speed equals 2. Hide in inspector. I should just copy and paste this. Public bool has target equals false. Hide in inspector, public game object target, and private rigid body 2D RB. All right, so I'm going to let this compile. We're going to drag it onto the player. The enemy, sorry. Okay, what we're going to see is for a script, we see our speed, but we don't see any of those public variables. So that's why that hide and inspector exists. Now we're going to add on a call to awake and update. Let's get rid of all this stuff. Awake and update. So we want to get the rigid body immediately. We don't want to wait until start happens. And our update is not tabbed appropriately for my liking. So update, if we have a target, calculate the vector to that target and then try to follow it. And units is basically a Unity generic form of measurement. We also have a bunch of other functions that I'm going to add in here too. So follow, this is not a default Unity function if you're wondering. Let's go ahead and now talk about each of these here. So we've got update, tab. Oh God, why are we auto tabbing when I shift? Okay, good enough. So we have added on untrigger enter 2D and untrigger exit 2D. So basically, if our bigger collider sees that somebody has entered or left that circle of influence, set the target to be that game object, and then set our internal variable that yes, we have a target. If I leave and that collider is the player object, we don't have a target, our Boolean is false. Our follow function is just to add a force, take my position, subtract it off, subtract the target's position. The target's position, subtract off from my position, normalize it, multiply the speed by it. And the speed is our public enemy variable there. Now we do have an issue which we have to check this player object here. So recompile. I did call it the right thing, fortunately. If you name your player object something different, you're going to have to change that. But here we're basically just seeing what is the name of the game object that we are colliding with here. Okay, so what we should have, if everything works out okay, is an enemy that just kind of follows us. Look at that, nothing's happening. Look at him not move. Okay. What have I forgotten? I know I forgot something in here. Speed is 2. Uh-huh. Do we need to go on the same layer? Don't think so. I fixed this last time and I forgot to add on the note to myself. Is it simply that is player object? Let's move you over here. I must have forgotten something somewhere. Do you have a script? You do have a script. Let's bump up your speed significantly. So what we do next, yeah, nothing's happening here. Okay. I don't bounce into you at least. Let's check our collider on the player. Oh, damn it. I've done this every single year I've taught this freaking class. Oh, God. Okay. Way back. Add a circle collider to the player as well. Guess who didn't do that? Me, again, for the 3rd time in a row. Set the radius to bound the object. Done. No trigger. Done. The sigh of frustration is self-induced. It's, why aren't you following me? We don't doubt your knowledge. Hey, you're a physics object now. We don't want that. It's like that scene from Gravity. No, Sandra Bullock, no. I need more caffeine. All right, why are we bouncing now? Are you a kinematic out? No, wait. I put that on the wrong thing. Reset. No, delete. Player object. Circle collider. Thank you. Okay. Let's make you a touch bigger. Okay, not trigger. Save, play. See if that worked. There we go. Hey. Wow, you just went off. Holy crap, where'd you go? It's fun. Enemy object. Let's make your speed down back to 2. Yeah, yeah, yeah. Look at that. Dreams do come true. Okay, so we have basically made this guy. If any of you remember the SNES era, this is the most frightening thing in the world from the 16-bit era, short of that clock tower game, I suppose. But what can we do? We now have an enemy where they follow us if we're in range. We're shooting bullets. Where would you take this next? Well, have the enemy spawn bullets if they're within range. Take that vector that they calculate to kind of follow you and start like shooting that in that direction. Maybe try to do a leading type of shot so that, it's in front of the player. Yes, Sinistar. Yes, great game. Add on a score. If you interact with a bullet, take off some hit points. If your hit points are down to 0, load in your game over scene, whatever you're going to do. I'm going to skip over this because it's just kind of extra if you want. We can add scriptable objects where, like if I were to right click in the asset manager there, I could say add a default weapon, add a 6-shot weapon, whatever I want to do. It's pretty straightforward, honestly. So you just add a script, and let me copy and paste this just to show you, because otherwise it's not going to make any sense. Copy, project, create, and let's call this weapon. Now I'm going to I'll go ahead and do this here. So I'm going to drop this in, and this is weapon.cs. Let's just call it weapon. It's a scriptable object, not a mono behavior. Okay. So we've got a nice little decorator here for adding onto the asset menu. This is still a weapon, but it's a scriptable object now, not a mono behavior. So this should compile. And if I right click, create weapon. And what did this get me? Well, I've got a kind of pre-baked, like it's basically a class that I can add on. I can store on bullet prefabs. So like if I'm shooting a laser instead of a bullet, I would just draw a massive beam going off into space. All right, so kind of the key here is that, again, I'm going to take this, I'm not going to go through all of this, but you would basically have a set of weapons that your player could cycle through. And rather than just kind of immediately internally scripting it out, did he press 1? Did he press 2? Did he press 3? Then shoot like a spread instead of a single bullet. I can just have it be an asset. And then I can save it as a game object, basically, and drag it onto my player. Unity's kind of nice in that little abstractive way. All right, questions from today. So what we're going to start with next time is I'm going to skip over the Git type of things because it's painful. And if you don't need to go through it, I'm not going to. But GitHub and Unity do not play nicely together. And if you're thinking of putting it a straight up Unity project under revision control with GitHub, it's a massive pain in the rear. I'll talk about it next time, but we're basically going to look at the shader graph, and we'll do your presentations then too. So, questions, comments, concerns? So this was all 2D stuff. Nope, smiley face. Like smiley face. Alrighty, well, I wish you all a delightful weekend, and I will see you on Tuesday. And don't forget, Tuesday will be Zoom. I'll send out an announcement with that as usual. We are coming up on the end game, so good luck. I love 2D. This is like just so much fun for me to dink with here. Alrighty, bye everybody. Have a good one.